Hi, today we are going to discuss the brief history of climate change research. This climate change research actually began with the greenhouse effect. Although there were some vague understanding among the ancient Greek that human can modify the climate through irrigating a desert, chopping down trees, but those were just hypotheses without any factual evidence. Back in 1824, French mathematician and physicist Joseph Fourier proposed that energy reaching the planet as sunlight must be balanced by energy returning to space since heated surfaces emit radiation. In another word, he actually meant as the sun is emitting energy and Earth's surface is getting it, so it cannot be possible that the sun is always emitting energy and Earth's surface is continuously absorbing it. In any way, Earth's surface has to give that energy back into the atmosphere. So he meant that um, when the Earth's surface gets heated, then this heated surface emit radiation, which means some of the sun's energy after getting absorbed by the Earth's surface is re-radiated back to the atmosphere. And then he said that this energy, this re-radiated energy, must be held within the atmosphere and not returned to space. And in this way, this energy keeps the Earth warm. He proposed that Earth's thin covering of air, its atmosphere, acts the way a glass greenhouse would. So which means energy enters through the glass walls but is then trapped inside, much like a warm greenhouse. So in this way, Joseph Fourier was actually first started to talking about something called the greenhouse effect. But unfortunately, nobody paid much attention to it as most scientists believe that humans can barely influence the global climate. However, the Irish physicist John Tyndall, he was working on he was doing research on the history of Alpine glaciers, and after 40 years of Joseph Fourier's proposition, he started to explore what kinds of gases were most likely to play a role in absorbing sunlight. His laboratory tests showed that coal gas, which contains carbon dioxide, methane, and volatile hydrocarbons, was especially effective at absorbing energy. He eventually demonstrated that carbon dioxide alone acted like a sponge in the way it could absorb multiple wavelengths of sunlight. He devised some public demonstrations, drawing huge crowds in both London and for international tours. In this way, he actually communicated with the policymakers and the public of that time. Despite Tyndall's commitment to public engagement, this idea was not very much popular, this greenhouse gas impact. But the Swedish chemist Arrhenius, he actually started to explore how decreasing levels of carbon dioxide in the atmosphere might cool the earth. In order to explain past ice ages, he wondered if a decrease in volcanic activity might lower global carbon dioxide levels. And his calculations showed that if carbon dioxide level were halved, global temperatures could decrease by about 5 degrees Celsius, which is 9 degrees Fahrenheit. Then he again wondered if the reverse were true. So he did another experiment and he found that uh, he found that the possibility he found that if the carbon dioxide level were doubled, the temperature could increase by the same amount, which is 5 degrees Celsius. And decades later, modern climate modeling have confirmed that Arrhenius' number were not far off the mark. That means he was very much correct. So by 1930s, we found more claims of greenhouse gas impacts on the atmosphere. British engineer Guy Stewart Callender noted that the United States and the North Atlantic region had warmed significantly on the heels of the Industrial Revolution. We'll know about more Industrial Revolution later. While Calendar's claims were largely met with skepticism, he managed to draw attention to the possibility of global warming. That attention played a part in garnering some of the first government-funded projects to more closely monitor climate and carbon dioxide level, which means that by 1930s people were quite concerned, and that's why government started to fund the different projects which can closely monitor the climate and carbon dioxide level. But note that people were not very much cautious about the fuel emission or how the carbon dioxide level can be decreased in these things. So although we found that there is a theory of anthropogenic global warming, people remain pretty unconcerned. They believe that the ocean would absorb most of the carbon dioxide. And back in that time, like around 100 years ago, human influence was not very significant like now, and water vapor was seen as the most influential greenhouse gas. In the 1940s, there were developments in infrared spectroscopy for measuring long-wave radiation. At that time, it was proven that increasing the amount of atmospheric carbon dioxide resulted in more absorption of infrared radiation. So Gilbert Plas summarized these results in 1955. He concluded that adding more carbon dioxide to the atmosphere would intercept infrared radiation that is otherwise lost to space, and in this way it warms the Earth. In As there were some government-funded projects were running on to monitor carbon dioxide levels, among those funded projects, most famous was a monitoring station established in 1958 by the Scripps Institution of Oceanography on top of Hawaii's Mauna Loa Observatory. So this is very much famous. If you go to Hawaii, you can actually visit this Mauna Loa Observatory, and we're still getting data from that observatory. So data from that observatory reveal that what would become known as Keeling Curve. So this Keeling Curve was named after the Scripps geochemist Charles Keeling. He was engaged in measuring the concentration of carbon dioxide in the atmosphere. This upward sawtooth-shaped curve showed a steady rise in carbon dioxide levels, along with short, jagged up and down levels of the gas produced by repeated wintering and greening of the northern hemisphere. So the zigzag pattern of this curve is actually because of the seasonality of the northern hemisphere. So in the winter time, when all the tree leaves fall down, then we have higher carbon dioxide, and when summertime, when all the tree leaves are there, we have lower carbon dioxide. So this Keeling curve, in this picture, you can see that it is measuring the carbon dioxide since 1960s. So back in 1960, the carbon dioxide level was only less than 320 parts per million. But currently in 2018, the latest reading is 412.24 parts per million. So for the first time in the history of the Earth, this carbon dioxide level increased so much. However, in the early 1970s, a different kind of climate worry took hold. It's global cooling. As more people became concerned about pollutants people were emitting into the atmosphere, some scientists theorized that the pollution could block sunlight and cool the earth. How is that? And when you have a lot of pollution in the air, which means a lot of gases, a lot of gas molecules in the air, and that gas molecules will reflect the sun's energy, will absorb the sun energy, and this is how they can block the sunlight. And if you don't have sunlight, which is and the earth's surface is not getting enough sunlight, then ultimately it will cool down the earth. So this theorization actually came because from 1940 to 1970 we had a post-war boom in aerosol pollutants which reflected sunlight away from the planet. However, as the brief cooling period ended and temperatures resumed their upward climb, warnings by a majority of scientists that Earth was cooling were dropped. So along with the Keeling Curve data, we also gathered some empirical data. Empirical data means the field level data. So this observatory data was the Hawaii Mauna Loa Observatory data was supplemented with empirical research studying air bubbles trapped deep in the Antarctic and Greenland ice caps. So this ice core data is a very much significant for climate change research. How is that actually? I mean, this ice cap, this ice cap. I mean, this ice core data is actually the natural time capsule. Um, I'm guessing that a lot of you have seen how the snow falls. When snowfalls happen, it looks like it's very soft. It's not very hard. Snowfalls happen. So when snowfall happens and the snow actually gradually accumulates over the surface of the earth, then there are a lot of air bubbles usually exist between those snow particles. And in this way, just think that year after year, for thousands of years, snow is accumulating in the Antarctic and Greenland ice caps, where there was no melting of snow. So this accumulated snow, if you just now consider the accumulated snow, and if you now think about the lower part of the snow, because of higher pressure from the above, that lower part will become solid ice, and the air bubbles that exist between the snow particles, that will actually prevail in that form. The air bubble will be always there, and that air bubble contains the atmospheric composition of that time when the snow fell. So usually in Antarctica, snowfall averages 2 inches per year in the continental side, and in the coastal side 10 inches per year. So now if you want to, in 2018, if you want to get the data, if you want to get the data, atmospheric data of like 2000 years old atmospheric data. So and now what can you do? You can actually dig down the ice core, and you can dig around 200 feet below the current surface level. And then if you can get the ice which have been formed like 2000 years ago, and you can actually then get the air bubbles and analyze the air bubbles and get the atmospheric composition. So in this way you can actually get the atmospheric composition that existed 2000 years ago in the world. So this data was very much helpful to analyze the carbon dioxide level in the atmosphere. So now, the time for action. The Keeling curve and the ice core data confirm that we are actually encountering global warming because of greenhouse gases. So in the 1972, we arranged the first United Nations Environment Conference. So this United Nations Conference was actually again established the United Nations Environment Program. In short, it is UNEP, UNEP. And this UNEP and the World Meteorological Organizations then established the Intergovernmental Panel on Climate Change, IPCC, in 1988. This IPCC is the leading international body for the assessment of climate change. It was established to provide the world with a clear scientific view on the current state of knowledge in climate change and its potential environmental and socioeconomic impacts. The IPCC reviews and assesses the most recent scientific, technical, and socioeconomic information produced worldwide relevant to the understanding of climate change. IPCC does not conduct any research, nor does it monitor climate-related data or parameters, but it actually assimilate all the empirical researches and provide us a review report. And if you now search, there are total, currently we had 5th IPCC report, and the 6th IPCC report is under preparation. So now if you search in the Google that IPCC report, you will get the latest report of 2014. Now, in 1992, at the Rio Earth Summit, the United Nations Framework Convention on Climate Change (UNFCCC) was established. It is a formal treaty, but it does not contain anything legally binding. Rather, it provides a framework for negotiating specific international treaties. Or to put it another way, it's an agreement to have a lot of meetings. So since then, actually since 1995, under the Conference of Party, all the global leaders meet every year to discuss the climate-related policies, climate-related negotiations. And this is the overall history, a brief history of climate change research. Thank you very much.